And we got project scheduling and resource planning for execution readiness. We have resource planning in here. One of the competencies shown, the topics shown, but the course project requires the RACI chart, which is the resource planning part of it. So that's why we'll talk about it here. And I don't know if I've said this to you guys. I know I've mentioned it to some of the other classes. I just want to make sure that the fact that you guys are here is not lost on me. It really shows me that you're committed to the course and your learning and your professional development and learning about project management, because there's a million other things that I'm sure that y'all could be doing. And your time in here and engagement in the course this way is valued. So I just want to make sure that I get that across. And it's not lost on me. Our agenda, this session builds on from scope to schedule to resource planning, and then we connect those elements to execution readiness and project deliverables. It's organized into several major sections. We'll begin by connecting last week's scope work to this week's focus on schedule planning. And from there, we'll examine how the project schedule is built through activities, sequencing, duration estimating, and critical path analysis and schedule development. And then we'll look at the tools that can support scheduling work, including dedicated scheduling software and spreadsheets. In the second half of the session, we'll extend planning into resource readiness by examining resource management, resource estimating, and role clarity through tools such as RAM or RACI charts. We'll bring these ideas together through integrated planning for execution. And then finally, we'll review the week 4 course project deliveries and do a little look ahead to week 5, where we move into cost and procurement and budget development. The transition to schedule and resource planning, project scheduling and resource planning translate the defined scope into coordinated execution ready work. This week builds directly on the work completed in week 3. The focus shifts to the next step in the planning progression, developing the project schedule, and identifying resources required to complete the work. The schedule answers an essential question: when and in what sequence will the work occur? At the same time, resource planning addresses who will perform the work and what resources are required. These processes are closely connected. Activities must be defined in sequences before they can be scheduled, and resources need to be identified before the schedule can be considered realistic. According to the process-based structure in the planning process group, schedule and resource planning are part of a broader integrated system of planning activities that refine the project management plan and prepare the project for execution. In the course project, this transition is reflected in the week 4 deliverables, where you'll develop schedule artifacts and begin identifying resource requirements to support project execution. Planning is not a set of isolated steps. It's a progression from scope definition to coordinated execution planning, where the schedule and resources work together to make the project achievable. In the course, we're kind of working through these stepwise in sequence. We have scope, now we schedule, and next we'll have cost. In practice, in reality, what happens is that they're all going along together. We'll plan some schedule, and then we'll identify resources. Then we'll look at the cost, and we'll go back and see how those changes affect the schedule. And you'll be doing this kind of in a collaborative sort of way, if you will. Planning, schedule, and resources, a connected process flow. The schedule and resource planning develop through connected processes within a broader project planning framework. This slide shows the connected planning flow behind week 4. Schedule planning begins with a broader project management framework and proceeds to define activities, sequence work, estimate durations, and develop the schedule. Resource planning develops alongside that work through resource management and resource estimating. The key idea is that these are connected processes that together help turn the defined scope into execution-ready plan. So we've got the schedule planning flow, we've got the main project management plan, schedule management, which is one of our deliverables, the schedule management plan, activities, sequences, and we're going to put all these together. Then we have the resource planning that kind of follows in that. And they got this little link here. That's to show that these processes are iterative and interactive with each other. With plan schedule management, the schedule planning begins by defining how the project schedule will be developed, maintained, and controlled. Once the broader planning framework is in place, one of the next steps is to determine how the schedule will be managed. That's the purpose of the plan schedule management artifact. Rather than building the schedule itself, this process defines the approach that will be used to create, maintain, and control the schedule throughout the project. In other words, it establishes the rules and structure for schedule planning before the detailed work begins. This includes selecting scheduling methods, identifying tools that will be used, determining the level of detail needed, clarifying how schedule performance will be monitored, reported, and controlled. These decisions are important because they help us ensure that later scheduling work is consistent, realistic, and manageable. In the text, the process group's practice guide, plan schedule management appears in the planning process group and produces the schedule management plan as a key output. That output helps guide the later processes of defining activities, sequencing work, estimating durations, and developing the schedule. The key idea is that schedule planning starts with method and structure, not with just a calendar alone. Before a project team can build a successful timeline, it needs agreement on how the schedule will be developed and governed. This also connects directly with the course project, where schedule artifacts should reflect a deliberate planning approach rather than just a list of dates and tasks. Define activities. Defining activities translate structured project work into actionable tasks that can be sequenced, estimated, and scheduled. After establishing how the work will be managed, the next step is to identify the specific activities that need to be performed. This is the purpose of defining activities. This part of it is essentially the next part of the work breakdown structure. So previously, the project scope was organized to the work breakdown structure. Now the work provided in a structured view of deliverables and work package. And so at this point, the effort becomes about more detail by translating those work packages into actionable activities that can later be sequenced, estimated, and scheduled. And one thing to note here is that kind of the official language is activities, but most people will call them tasks. If you're using one of the scheduling tools like Microsoft Project, it'll call them tasks. I think Primavera calls them tasks, but we use them in practice. We use them interchangeably. This is important because work packages are still relatively high-level planning components. To build a workable schedule, the team needs to identify the actual tasks or activities or actions required to complete the work. Defining activities provides that bridge from structured scope to actual scheduling detail. This process produces several important outputs: the activity list, which identifies the activities to be performed; activity attributes, which captures supporting details about those activities; and the milestone list, which identifies significant points or events in the project. Scheduling doesn't begin with dates on a calendar. It begins by clearly identifying the work that must be actually performed. Once activities are defined, the project team can then determine their relationships and estimate their durations and build the schedule logic. And we build that schedule logic through the sequence activities. Sequencing activities establishes the logical relationship that organize project work into a coherent schedule flow. Once activities have been defined, the next step is to determine how they relate to one another. This is the purpose of sequence activities. At this stage, the project team is no longer asking only what work must be done, but in what order that work should occur. Some activities can begin only after others are completed, which is called a finish to start relationship, while some may overlap or occur in parallel, which is some kind meant to be a start to start relationship. And sequencing activities identifies these logical relationships and organizes the work into a structured flow. This process is important because a schedule is not simply a list of activities, it's a network of connected work. The logic among activities helps determine the path the project will follow and shapes how the schedule will later be developed. The PMBOK guide describes this process as producing the project schedule network diagram, which visually represents the sequence of activities and their dependencies. This creates an important foundation for later duration estimating and schedule development. Sequencing creates workflow logic. It helps the team understand how work moves through the project, where dependencies exist, and the coordination that will be required. So on the slide, we've got this activity list here, and what we do here is we take those and lay them out in the sequence that need to be done. And you can see in here they've got activity C kind of breaks down into these activities here. They're showing this, all this is parallel work here with E and G and these milestones. This is kind of typical how this might work. This is called a activity on node type of diagram. We don't need to get into the details for the course. What we're looking for the course project is something really high level that shows just basically a logical flow throughout the schedule that you put together. Estimate activity durations. Estimating activity durations assesses how long project work is expected to take and strengthens the realism of the schedule. Once activities have been defined in sequence, the next step is to estimate how long these activities are expected to take. This is the purpose of the estimate activity durations. At this point, the project team has identified the work and established its logical relationships. The remaining question is how much time will be needed to complete each activity. Duration estimating helps answer that question by applying judgment, assumptions, experience, and available planning information to determine expected time requirements. My advice has always been on projects is that go to the people that are doing the work and ask them to help provide estimates. If you have empirical evidence like past performance on similar work, you can drive your estimates based on that empirical evidence, which is a lot of the adaptive approaches use that type of planning. But they're looking at shorter time periods and usually smaller teams. But so it's a little easier to measure and get that empirical information, but it's important. This process is important because schedule logic alone is not enough to create a workable schedule. The team needs credible time estimates. If duration estimates are weak or unrealistic, the entire schedule can become unreliable, even if the sequencing logic is sound. The PMBOK guide identifies activity duration estimates and the basis of estimates as important outputs of this project. These outputs help explain not only the estimated time values, but also the reasons and assumptions behind them. That supporting information becomes especially important when estimates must later be reviewed, updated, or challenging. Yes, this information, and it also gives you a good way to look and see, well, this was our rationale, our reasoning for this. How come we're not performing the way we estimated? And it does help you for root cause analysis. Durations are not exact predictions. There are reasoned estimates based on the information available at the time. This means that estimating also introduces an awareness of uncertainty, assumptions, and potential variation in project timing. Estimating activity durations and some core estimating methods. Activity duration estimates are strengthened by using appropriate estimating methods rather than relying on guesswork alone. And one thing to note, and I'm not sure if I mentioned it here in this presentation or not, but many of the same estimating techniques can be used to estimate time and cost. So when we get into budgeting, we'll see some of the same estimating techniques being used. They overlap a lot. So once activities have defined, the project team needs a credible way to estimate how long the work will take. PMI defines several core tools and techniques that support this effort, and together they show that duration estimating should be approached as a reasoned planning activity rather than just guesswork. The first is expert judgment. This means relying on the knowledge and expertise of people who are familiar with the type of work being performed. In many projects, the most useful estimate begins with a judgment of the person or the group who best understands the activity or is actually going to perform that activity. The second method is analogous estimating, which uses similarities to prior work to estimate the duration of current activities. This approach is often faster and can be useful when detailed data are limited, although it may be less precise than methods built from more specific information. PMI also identifies another estimating technique called parametric estimating, which is a form of analogous estimating, which uses known rates, units, or formulas to generate estimates. For example, a team knows how long a standard unit of work usually takes. That information can be applied to the current activity. Like if you take your car, if you have an accident in your car and you take it to the body shop, they know how long it takes to put that fender on there. Matter of fact, they probably have a database somewhere with all these estimates in it, and they can go back and look at those and parametrics, those metrics, and just apply them into your estimate. And they're usually pretty good. Another important method is something called three-point estimating, which accounts for uncertainty by considering more than one possible outcome rather than assuming a fixed value. This helps us see that duration estimates are not exact predictions, but informed judgments made under conditions of uncertainty. Three-point estimate uses something called a PERT analysis, where we do the pessimistic estimate, the most likely estimate, and the optimistic estimate. We multiply the most likely by 4 and add all those together and divide that number by 6, and it comes out with a single point estimate. And the best way to say that is to communicate that to people is that we think it's going to take 4 hours plus or minus, and you use the optimistic and the pessimistic. So plus 3 hours plus the pessimistic of maybe 8, and optimistic maybe a 4 or 2. And so you give them a range instead of a point estimate. It's usually better for you. It gives you some flexibility. And then we have bottom-up estimating, which develops estimates from the lower level components of the work and then aggregates them upwards. This usually takes more effort, but it can prove precision because it's based more on detailed planning information. The bottom-up estimating is usually considered to be the most accurate form of estimating project work. And it includes going to creating that work, the activities, defining what those activities are, and then estimating everything at activity level, and then aggregating all the activities into the work packages, and then aggregating all the work packages together into the project overall budget or cost estimate. For the course project, you're going to be asked to create a meaningful project schedule, milestone lists, and resource requirements and critical path documentation. This means that the estimate should reflect a reasonable approach, not just arbitrary durations. But we're still high level in the course project. Different estimating methods provide different strength. Good project planning involves selecting an estimated approach. This would be one of the things you do in that plan budget or plan estimating, plan cost part of it. That fits the level of detail, the quality of available information, and the uncertainty of the work being performed. Improving estimate quality. Reliable duration estimates depend on analysis, collaboration, and documented estimate rationale. In addition to the core estimating methods, PMI identifies several supporting techniques that improve the quality and credibility of duration estimates. These techniques remind us that estimating is not only about choosing a formula or a method, it's also about analysis, collaboration, documenting the reasoning behind the estimate. One of these supporting techniques is data analysis. PMI includes examples of alternatives analysis and reserve analysis. Alternatives analysis helps the project team compare different approaches for performing the work, which may affect the expected duration. Reserve analysis helps the team consider whether additional time allowances or buffers may be needed to account for uncertainty or risk. Together, these forms of analysis strengthens the estimate quality by encouraging more thoughtful evaluation of how the work may actually unfold. Another support area is decision making, including approaches such as voting. This is useful when multiple stakeholders or experts or team members contribute to estimating, and the group needs to align on a reasonable value or approach. In practice, this reinforces estimating and can be both analytical and collaborative. There's something called the Delphi technique that we use to do this kind of voting, or we do real quick fists of 5, and we just throw out numbers and everybody votes on them. And it's a quick way to do it. The Delphi technique can be anonymous if you want that. The adaptive methodologies have something called a story poker, and what that is, estimating poker, and you have cards. That's where the poker comes from, and you vote on how long you think it's going to take to do something, what the estimate is by the number on the card. They use a Fibonacci sequence. So you have numbers like 1, 2, 3, 5, 8, 13, 21, and so on. How you would do, and it's usually voted relative to the easiest activity. And it sounds complicated, but it's really pretty easy and straightforward. But it's a type of Delphi technique. PMI also identifies meetings as a supporting techniques. Meetings allow the team to review assumptions, compare perspectives, clarify the scope of activities, and build a shared understanding of what the estimate should represent. This is especially helpful when teams depend on specialized expertise or when work crosses functional boundaries. Just as important is the basis of estimates, which documents the assumptions, the rationale, the constraints, the confidence considerations, and supporting logic behind the estimate. This matters because duration estimates are not fixed truths. They are planning judgments based on the information available at the time. As planning becomes more detailed, estimates can be progressively refined and improved. Better estimates come from disciplined thinking, not just from picking a number. Analysis improves rigor, meetings improve shared understanding, and documented rationale makes the estimate more transparent and defensible. That is especially important in the course project where the schedule decision should show a credible planning basis rather than arbitrary assumptions. Okay. Critical path highlights the work that directly derives schedule duration. The critical path identifies the sequence of activities that determines the project's shortest possible duration. And it's confusing, but it's also the longest path through the project. Once the schedule logic and duration estimates have been integrated, the project team can identify the critical path. This is one of the most important concepts in schedule development because it highlights the sequence of activities that determines the shortest possible time in which the project can be completed. What it means is there's no slack or float between those tasks. So task A has to finish on time, or it's going to cause a delay in task B, which is going to cascade into C, D, and all the way and push the end date out. And then we have to start doing some schedule crashing or parallel work. You start looking at restructuring the schedule. Critical path is not simply the set of the most important task. It's the longest path through the schedule network, meaning it's the chain of dependent activities that directly derives the overall project execution. If one of these activities is delayed, the project completion date is also delayed unless we take corrective action. This makes the critical path especially valuable for project management. It helps a team distinguish between activities that have scheduling flexibility and those that do not. In other words, it focuses attention on the work that is most schedule sensitive. In our text, the Process Groups of Practice Guide, critical path method is associated with schedule development is one of the key ways project teams analyze schedule logic and overall project timing. For the course project, identifying a critical path is one of the required schedule artifacts, and it means that we're not expected to list activities and date, but we're also to show the sequence of work that drives project duration. Critical path helps transform a schedule from a simple timeline into a management tool, and it shows where the schedule risk is concentrated and where close attention is most needed. The next process is develop schedule. Developing the schedule integrates activities, logic, durations, and resources into a workable, time-based project plan. After activities have been defined, sequenced, and estimated, and after resource needs have been considered, the next step is to integrate that planning information into a workable project schedule. This is the purpose of the develop schedule process. At this point, the project team is no longer working with isolated planning elements. The team now has activities, logical dependencies, duration estimates, and resource information that must be brought together into a single time phase view of the project. The schedule becomes the mechanism for organizing when work is expected to occur and how that work fits together over the life of the project. This process is important because it turns planning components into an operational timeline. Instead of having only a list of tasks, a network of dependencies, or a set of estimated duration, the team now develops a schedule that shows the intended timing and coordination of the work as a whole. The PMBOK identifies outputs such as project schedule data and project calendars and the schedule baseline. These outputs help the project team communicate the plan, coordinate execution, and later monitor schedule performance. Developing the schedule also makes milestone timing more visible and helps the team recognize whether the plan appears realistic, coordinated, and achievable. And this is where we need to see how scheduling becomes more than just documentation. It becomes a central tool for project execution and later project performance management. The course project requires not only schedule planning, but also practical schedule artifacts such as a milestone list, a network diagram, and a schedule presentation of some time. Our Gantt chart would be nice. Those deliverables depend on integrating the prior planning work into a coherent schedule view. The schedule is not created from one input alone. It's developed by integrating multiple planning decisions into a realistic time-based execution plan. Scheduling software supports schedule development. Scheduling tools help support project teams integrate, visualize, update, and control schedule information more effectively. Once the project team reaches the point of developing the schedule, Dedicated scheduling tools can make the process much more manageable. In practice, software such as Microsoft Project, Primavera P6, or Smartsheet, and I think Monday.com, and there's a few others. These tools help teams organize activities, apply dependencies, enter durations, assign calendars, identify milestones, and generate timeline views. They're especially useful because they bring multiple planning elements together in one environment. Instead of managing all these things separately, the team can integrate them into a structured scheduling model. This supports the purpose of developed schedule, which is to produce a workable time-based plan from multiple planning inputs. Scheduling off software improves visibility, Gantt charts, network diagrams, milestone views, calendars, baseline features, and allow the team to communicate the schedule more clearly and monitor more systematically over time. At the same time, we should remember that software does not create a good schedule by itself. A tool can organize and display scheduling information, but it doesn't replace sound judgment about activity definition, logic assumptions, uncertainty, and realism. Good scheduling still depends on good planning. This means for the course project, you can use software tools if you have them to present the schedule artifacts, but the quality of schedule, regardless of the tool, it depends on the underlying planning logic. Make sure that it's credible and well supported. There's a free tool. It's called Project Libre, and I think that means free project. And it's essentially a Microsoft Project clone. So if you want to play with that, that's great. You can also use good spreadsheets to put together a schedule. So spreadsheets can support simpler schedule development for smaller or less complex projects. Spreadsheets can support scheduling, but they offer less automation and control than dedicated scheduling tools. A spreadsheet can be used to organize activities, assign durations, note start-finish dates, identify milestones, and even create a simple Gantt-style presentation. For practitioners working on a relatively straightforward efforts, this can be practical and an accessible way to build a schedule. This flexibility is one reason that spreadsheets remain in common practice. They're widely available, easy to edit, and useful for presenting planning information in a familiar format. In many cases, they work well when the project does not require advanced dependency logic, detailed calendars, or frequent schedule recalculation. However, spreadsheets also have limitations. Dependencies are usually handled manually. Schedule updates may require more rework, and features such as baselines and automated recalculation and advanced schedule analysis are less robust than they are in dedicated tools. This means that the project complexity grows. Spreadsheet can become harder to manage effectively. Spreadsheet-based schedule still may be appropriate, especially for the course project, if it clearly communicates activities, timing, milestones, and planning logic. The important issue is not the software, but it's whether the schedule is meaningful, readable, based on a sound planning approach. You may be able to find a Microsoft Excel schedule template out there somewhere. You just have to search on the web and see if you can find it. And you could also maybe take your dependency list, your activity list with all the dependencies, and try putting those into the AI, into Infinity, and say, hey, create me a schedule based on these activities and these dependencies and these durations, and see what happens and see what kind of outputs you get. The key takeaway is that spreadsheets can be useful in scheduling tools for simpler situations, but they're generally best suited for lower complexity planning and presentation needs rather than on more advanced schedule control. Resource planning extends schedule planning into execution readiness. After the schedule is developed, resource planning helps determine whether the work can be staffed, assigned, and carried out realistically. Up to this point, we focused on how the project works is organized over time. Here we began with schedule planning, moved through activity definition, sequencing, duration estimating, and schedule development, and then looked at how software and spreadsheets can help present and manage that information. But a schedule alone is not enough to make a project executable. A project timeline may show when the work is supposed to occur, yet the plan is only realistic if the required people, roles, and other resources are available to perform that work. This is where we shift into resource planning. In the planning process group, the plan, resource management, and estimate activity resources extend the logic of the schedule development by identifying how resources will be structured. aligned and quantified for the work ahead. This transition is important because it includes not only the schedule artifacts, but also resource requirements, project roles and responsibilities, which can be viewed or displayed in a RACI or a responsibility assignment matrix, which help us move from a real-time plan to a more execution-ready plan. Scheduling and resource planning are closely connected. The scheduling shows when work should happen, while resource planning helps determine whether that timing is feasible, coordinated, and supported. Together, they create a stronger foundation for execution and later project performance management. You may have what we call constrained resources, and you may have an activity that needs to happen on a certain date, but the resource that you have for that may not be available. So, like you're building a house and you need to pour concrete on a certain date, but in order to do that, you're going to need the concrete truck and the materials to transport the concrete. Well, what if it's scheduled for another job on that day and it's constrained by that other job? So you're going to have to readjust your schedule. And again, as I mentioned, that's how they kind of work interchangeably there, how they're integrated. Plan resource management. Resource planning begins by defining how project resources, roles, and responsibilities will be structured and managed. Resource planning is the first step to define how project resources will be managed. This is the purpose of the plan resource management. Like plan schedule management, this process doesn't yet assign all the resources or quantify every requirement. Instead, it establishes a framework for how resources will be approached, organized, and governed throughout the project. That includes both team members and physical resources. Another way to describe team members in this term is you can call them labor resources. That's another, you might see that mentioned. A major part of this process is defining roles and responsibilities. The project team needs clarity about who is accountable for different areas of work, how responsibilities will be communicated, and what reporting relationships will support coordination. This is one reason the process is so important. It creates structure before detailed assignment decisions are made. The PMBOK guide identifies the resource management plan as the key output of this process. That plan helps document how resources will be acquired, managed, developed, and controlled. It provides an important basis for later estimating and assigning and assignment activities. This process is relevant for the course project because it includes resource requirements and project roles and responsibilities. This requires thinking beyond the schedule itself and begin identifying how work will actually be supported by people, roles, and other resources. Resource planning starts with structure and governance, and before the team can decide exactly who will do the work or how much of each resource is needed, it must first define how project resources and responsibilities will be organized and managed. Estimate activity resources. Estimating activity resources identifies the types and quantities of resources needed to realistically perform project work. After the resource management approach has been identified, the next step is to estimate the actual resources required for the work. This is the purpose of estimate activity resources. At this stage, the project team moves from a general framework for managing resource to a more specific analysis of what each activity will require. This includes identifying the type of resources needed and the quantity required to complete the work. Those resources may include people with specific skills, equipment, tools, materials, facilities, or other physical assets. This process is important because a schedule may appear logical on paper, but still be unrealistic if the required resources are unavailable, insufficient, or poorly matched to the work. Estimating activity resources helps test whether the planned work can actually be supported in practice. The PMBOK guide identifies outputs such as resource requirements, which specify what is needed for particular activities, and a resource breakdown structure, which organizes resources into categories for planning and control. Those outputs strengthen later decisions about assignment, coordination, and monitoring. For the course project, we'll work to identify resource requirements as part of the schedule planning artifacts. It means that the plan should show not only when the work is scheduled, but also the resources it needs to carry out. The key takeaway here is that resource estimating helps connect the schedule to execution reality. It turns planned work into supportable work by identifying what resources are actually needed to perform activities. RACI clarifies project roles and responsibility assignments matrix, or responsibility assignments. The RACI, or responsibility assignment matrix, clarifies who is responsible, accountable, consulted, and informed for project work. And it looks like kind of like this on the screen here. RACI helps the project team identify who's responsible for doing the work. So that's the ones with the R. Who's accountable, someone with the A's. Who's accountable for ensuring it's completed, and who should be consulted before or during the work, and who should be informed about progress or outcomes. This creates a clearer picture of how work responsibilities are distributed across the project. This matters because project schedules and resource estimates alone do not fully explain how coordination will occur. A project may have the right activities and the right resources identified, but execution can still suffer if the roles are unclear or overlapping. The RACI helps reduce confusion, duplication, and accountability gaps by making role expectations more explicit. In the context of planning, this artifact strengthens the connection between activities, resources, and governance. It helps translate resource planning into practical coordination by showing how people and roles relate to specific work elements. In the Process Groups of Practice Guide, it includes the responsibility assignment metric concepts among the tools and techniques used to support planning and resource coordination. This is important for the course project because week 4 explicitly includes the project roles and responsibilities in a RACI charts or what's called a responsibility assignment matrix. It's similar to the RACI chart, it just doesn't have the informed part on it. The RACI chart is more usable, more effective. The key takeaway is that the RACI adds an accountability layer to planning. It helps move the project team from knowing what work is scheduled and what resources are needed to knowing who's expected to lead, support, advise, and stay informed as that work is carried out. Integrated schedule and resource planning strengthens execution readiness. Project execution becomes more realistic when schedule logic and resource requirements and role clarity are developed as one connected planning system. At this point, the major week 4 planning components come together. The project team has moved from defining and sequencing activities to establishing durations to developing schedule and then into identifying resource needs and clarifying roles and responsibilities. It's an important point that these are not separate administrative tasks. They work best when treated as an integrated planning system. The schedule provides a time-based structure for the work. Resource estimating defines what people, skills, tools, materials, or equipment are needed to support that work. The RACI, or the responsibility assignment matrix, clarifies how accountability and coordination will be distributed across the team. And when these elements are developed together, the project becomes more executable. The team is better able to judge whether the plan timing is realistic, whether resources are sufficient, and whether responsibilities are clear enough to support effective execution. This integrated view is consistent with the planning emphasis in the process groups of practice guide or in the PMI documentation, where planning processes interact rather than operate in isolation. Outputs from one process become inputs to others, creating a connected planning structure that prepares the project for execution and later control. So this speaks to my assertion that in real life, in practice, these things are kind of going back and forth. You find a resource over here, maybe they're not as skilled as other resources, and so it's going to take them more time. You got to update the schedule. It may cost you more, so you need to update the budget and go back and forth until you come to a consensus with the team that you've done enough planning. So week 4 is not about just creating a schedule, but it's about producing a set of planning artifacts, such as the schedule approach, activity logic, milestone structure, critical path, resource requirements, and project roles and responsibility. All these together make the project more execution ready. Effective planning is integrated planning. A timeline alone is not enough, and resource lists are not enough. The project becomes stronger when time, resources, and accountability are planned together. So let's look at week 4. The project turns the project step 3, week 4 course project step 3, assignment overview and deliverables. The week 4 project work turns scope and activity planning into a usable schedule package for execution. So this week's project activity asks you to move from scope definition into time-based planning, using the scope baseline in the WBS as inputs that we created earlier. Organize the work into a practical schedule that identifies the activities, shows the sequence, timing, and milestone structure. This matters because schedule begins to translate the project from a defined scope into coordinated execution. This is the third step in the 9-step project lifecycle that we're applying here, and it's to develop the project schedule. So once we've defined the scope and activity objectives, it becomes possible to organize the work in a meaningful schedule. In practice, though, the schedule development often occurs alongside scope and budget planning, and it's usually iterative rather than one and done, as I mentioned. And for the assignment, we're keeping the deliverable simple but meaningful. This step draws on several related processes, including plan schedule management, define activities, sequence activities, human resource planning, estimate activity resources, estimate activity duration, and develop schedule. According to our text, the plan schedule management establishes how the schedule will be developed and controlled. It includes selecting a schedule methodology, such as critical path method, and a tool, Excel or MS Project, or some other tool. The remaining processes help define the activities, sequence of work, and estimate resources and durations and develop the schedule itself. The end product is the project schedule baseline, which is the approved version of the schedule model with the planned start and finish dates. For this part of the course project, you'll produce the schedule management plan or statement, a project milestone list, resource requirements, and roles and responsibilities using a RACI or a similar responsibility assignment matrix, and some kind of project schedule. Be sure your schedule identifies the project's critical path. And now we can look ahead to week 5, which is developing the project budget. Week 5 extends planning from schedule development into cost, procurement, and budget baseline creation. And there's going to be a special note on procurement. The PMBOK 8 has really kind of changed how procurement is viewed from a project perspective. They define it more as an organizational function and less of a project activity. They've changed it from procurement to sourcing, and we have a sourcing strategy. And so we'll still do the procurement in here because procurement is still important to understand how it works in your project. But the point is that in modern projects, most of procurement activities handled by some corporate function some way. It's been 20-something years since I've worked on a project where I actually had to worry about contracting and soliciting bids and all of that kind of, and then enforcing contracts and making payments and all of that sort of work. Mostly what I've had is had either if the project was big enough, we had somebody assigned to the project from the legal or procurement department, or we had a point of contact in those groups that the project manager would communicate with once we had our sourcing strategy. We would submit that sourcing strategy that tells that department what the project needs, and it's their job to go out and solicit vendors and obtain contracts for the work that's being planned. So that's one big change. But week 5 is the 4th step in the 9-step life cycle, and we're going to develop the budget. And once the team has established the scope, objectives, the schedule, the project manager can begin finalizing the budget. And in practice, the budget development often occurs alongside the scope and schedule planning, and it's typically iterative. This step uses several connected processes, including plan procurements, now called sourcing strategy, plan cost management, estimate costs, and determine budget. The cost management plan establishes the criteria and format for planning, estimating, budgeting, and controlling project costs. And as I mentioned, a lot of the estimating techniques that we see for schedule, we can just turn right around and apply those to the cost as well. Procurement planning is also important at this stage because any procurement-related cost must be known before the budget is complete. For this portion of the course project, you'll develop a cost management plan or statement, a procurement management plan or statement, an activity and procurement cost estimates list, and a cost performance baseline. So week 5 builds directly on the schedule work from this week and extends planning into financial readiness for the project. So that's the end of my presentation. And remember that I value your time and effort and your commitment to the course. Any questions, any concerns? I will see you next week. All righty.
Thank you.
Good night.